Obviously, I knew if anything went wrong, I knew, like with cars, straight on the phone with my dad. He was always the money guy as well. So if I needed any advice about like money or what to do, I've never rebuilt an engine. I knew my dad had.
A $6 million hypercar, one of only 60 ever made, declared officially dead by the very company that built it. What happens when a British YouTuber takes on the impossible task of bringing that car back to life without any factory support, original parts, or permission?
Bugatti sue you for your share on rebuild?
I think it's become like a Lionel Messi, Ronaldo situation, but it's when the corporate world gets like mixed into it. So it looks way worse.
This is not just a story about fixing a wrecked machine. It's a dramatic collision of innovation, stubborn determination, and a challenge to the exclusive world of elite automotive engineering. Can one man really do what Bugatti's top engineers say cannot be done? The Locked VIN Challenge. Almost as soon as Matt Armstrong began his work on the crashed Bugatti Chiron Pur Sport, he encountered a barrier unlike anything most car restorers have ever faced. Bugatti had locked the car's vehicle identification number, or VIN, effectively erasing this particular machine from its official systems. What that meant in practice was that no Bugatti dealership anywhere in the world, from Europe to the United States, would supply any parts or support for the car. This move wasn't just frustrating, it was a full corporate blockade to the rebuild. The VIN lock carried enormous consequences. Imagine trying to restore one of the world's rarest hypercars without access to any factory parts or technical assistance. Every panel, every bolt, every specialized component was suddenly inaccessible through normal channels. Bugatti's decision was clear. They would not officially recognize or service this car because it had been declared a total loss. This was not a mere service refusal. It was a statement about control, ownership, and the boundaries of independent repair in the hypercar world. Behind that sealed door stood a $6 million machine with complex engineering unlike almost anything on four wheels. The locked VIN meant Armstrong and his team had to find alternative methods to source, recreate, or fabricate every part needed. Given the technical precision involved in maintaining a car like the Chiron Pur Sport, even a small deviation could cause major failures. The challenge was no longer just mechanically daunting, it became a question of whether the rebuild could happen at all. Bugatti's leadership made their stance very public. Mate Rimac, the company's CEO, voiced sharp concerns over the feasibility and safety of such an independent restoration. He highlighted critical damage, especially to the gearbox housing and the central structural tub that holds the car together. Rimac underlined the risks, suggesting that only 2 facilities worldwide had both the authority and capability to perform such complex repairs. Armstrong's workshop in the United Kingdom was explicitly not among them. The locked VIN became a symbol of exclusivity in the automotive world, a reminder that some machines are meant to live only under the care of their original makers. For most, this would have ended any hope of repair or comeback. Yet Armstrong's determination was different. The question was no longer just about fixing a car. It was about whether a private individual could push past the gatekeepers of elite engineering and rewrite the rules that had been set. This obstacle set the stage for a standoff between a resourceful outsider and a legendary car manufacturer. It forced Armstrong to not only rebuild a machine, but also to navigate legal, technical, and corporate barricades. Something extraordinary was unfolding here, but the full story of how that barrier was breached would only become clear after multiple breakthroughs and setbacks. Facing the locked VIN was just the beginning. Understanding why this machine was so exceptional is the next key to grasping the scale of what Armstrong was about to undertake. Understanding the Chiron Pur Sport. To appreciate the magnitude of the challenge Matt Armstrong faced, you first need to comprehend the extraordinary nature of the Bugatti Chiron Pur Sport. This isn't simply an expensive car, it's one of the most technically sophisticated machines ever built by human hands. Bugatti produced just 60 of these models worldwide, each one handcrafted with meticulous attention to detail that stretches the limits of automotive engineering. The base price for a Chiron Pur Sport starts around $4 million to $4,500,000. But for most buyers, the final tally climbs to nearly $6 million once customization and options are added. Every panel is hand-finished. Each piece of carbon fiber is carefully inspected, and the monocoque chassis forms a rigid shell that is both ultra-lightweight and incredibly strong. This car isn't just about speed, it's about precision engineering at a level few outside the industry have ever seen up close. Under the hood sits a quad-turbocharged 8-liter W16 engine producing 1,500 horsepower, a figure that places it in a league closer to spacecraft than sports cars. The cooling system itself is astonishing, featuring 10 separate radiators, far beyond the single radiator expected in most high-performance vehicles. These radiators work together to keep the engine running at peak performance, even under extreme conditions. Aside from raw power, the Chiron Pur Sport is a masterpiece of engineering compromises and innovations. Every inch of the car is designed to function perfectly, with no room for error. As Matt Armstrong learned firsthand, even components that seem simple, like the accelerator pedal, might be made from unexpected materials or designed around very specific tolerances. This complexity makes any repair or rebuild a task of extraordinary precision and understanding. Because of its rarity and engineering depth, most owners entrust these cars to exclusive service centers that have special tools, software, and access to proprietary parts. The manufacturer's control is part of maintaining the car's performance and safety standards, but also limits independent work. This creates an environment where a restoration attempt like Armstrong's is not just unusual, it's unprecedented. When Alex Gonzalez crashed his Chiron Pur Sport in Miami, the damage was catastrophic not only in cost, but in complexity. The repair quote from Bugatti for close to $2 million shocked many, and the decision to write the car off entirely added a new layer of difficulty. Rebuilding such a machine is not just about fixing crushed panels, it requires intimate knowledge of a supercar designed to exacting standards few can replicate. With this background, the true scope of Armstrong's task comes into sharper focus. But before we explore how the rebuild began, it's important to understand what exactly was damaged and why Bugatti felt justified in declaring the car beyond repair. The crash and official verdict. When the Bugatti Chiron Pur Sport crashed in Miami, the visible damage was severe. The front end was completely crumpled, the iconic horseshoe grille was shattered, and critical body panels, including the hood and headlights, were lost. Most notably, the airbags had deployed, signifying a serious impact that triggered the car's advanced safety systems. But beneath that surface wreckage lay far more daunting problems. The crash had forcibly shoved the engine forward inside the chassis, crushing coolant pipes and damaging surrounding components in ways that are often invisible at first glance. More troubling was the breakage of the cast aluminum engine mount, a key structural element that supports the entire powertrain. Such damage called into question not just the car's drivability, but its very safety. Bugatti's official stance was clear. Repairing this car would cost roughly $1,700,000, a figure that did not take into account buying a new vehicle, only the rebuild itself. For the owner, Alex Gonzalez, that quote was prohibitively expensive, too high to justify repair over replacement. The insurance company subsequently declared the car a total loss and issued a salvage title, effectively blacklisting it from traditional repair pathways. Once sent to a Copart auction, a marketplace where most cars are sold for parts or scrap, this Bugatti's future seemed bleak. Even among wrecked vehicles, few possess the extreme rarity and technical complexity of the Chiron Pur Sport. Most would have accepted defeat at this point, writing off the car as beyond hope. But Matt Armstrong saw something different. Known for resurrecting brands like Ferrari, Lamborghini, and McLaren from similar unsalvageable states, he recognized an opportunity. Owning a workshop filled with creative engineers and machinists, Armstrong was ready to confront the doubts of the experts. The fact that Bugatti itself had declared the car dead made the challenge all the more compelling for him. Choosing to repair the car, independent of Bugatti's official service centers, added further hurdles. Without parts, factory data, or official support, Armstrong was venturing into territory no one had mapped out before. A high-stakes gamble few outsiders could even imagine. The consequences of failure would be enormous, but so would the rewards if he succeeded. This collision of catastrophic damage and corporate refusal to help set the stage for what would become one of the most extraordinary rebuilds in automotive history. The real story was only just beginning to unfold. The path from catastrophe to resurrection required solutions that transcended typical repair, as we will see next. Independent rebuild begins. Once Matt Armstrong and his team decided to take on the Bugatti Chiron Pur Sport, they faced a daunting reality. No support from the manufacturer and no way to order official parts. Bugatti's locked VIN meant they had to rebuild the car entirely on their own. This was not just a repair, it was a ground-up reconstruction of one of the most advanced road cars ever made. And they had no factory blueprint to follow. Armstrong approached the challenge with a mix of boldness and methodical planning, knowing they had to create or fabricate virtually every single component. The first major hurdle lay in accessing the transmission, which Bugatti's CEO, Mate Rimac, had said could only be repaired by physically splitting the car in half. This meant separating the front tub, holding the cockpit and front suspension from the rear drivetrain frame. According to Rimac, only 2 facilities worldwide possessed the knowledge and clearance to tackle such a procedure, and Armstrong's workshop was not one of them. Despite this, Armstrong's team meticulously documented and disassembled every connection, from battery terminals to coolant lines, with utmost care. With patient and calculated effort, they managed to separate the 2 halves of the chassis using what they called gentle persuasion. The sight of a $6 million Bugatti Chiron divided was unprecedented, a feat that stunned even industry insiders. But the real shock came when the true extent of the crash damage was revealed. The impact had pushed the engine forwards, squashing coolant pipes and damaging critical mounting points. Most alarmingly, the cast aluminum engine mount support was broken, a failure that threatened the entire rebuild. This moment was a turning point. Armstrong discovered that Mate Rimac himself had been following the progress through online videos, watching a rebuild that his company had declared impossible. The stakes were higher than ever, but Armstrong's team pressed on undeterred. They understood that every part needed to function perfectly, or the car would never run safely or reliably again. Next, a particularly fascinating challenge emerged with the gearbox mount. Bugatti designs this mount to fail deliberately in crashes, a safety feature meant to absorb impact forces and protect the rest of the drivetrain. This meant the mount was intentionally fragile and could not simply be replaced with a new factory part, since none were available due to the locked VIN. The solution surprised many. Armstrong hired a specialist to TIG weld the broken mount back together. Welding a component designed to snap was widely assumed to be impossible, but it worked, restoring the mount's structural integrity. Following repairs, the 2 halves of the car were bolted back together using 14 titanium bolts torqued to specification. For a team that had never previously attempted such a rebuild, this was both a technical and symbolic milestone. A hypercar, once declared dead, was now reassembled piece by piece by a determined group willing to challenge the limits. The next big challenge lay ahead, and it was a task that would test their ingenuity further. Amid this complexity, one person came to symbolize the skilled craftsmanship behind the scenes: Bob from the machine shop. When the team needed a replacement front crash bar, a crucial structural component, there was no factory part to be had. Bob spent 60 hours building a new crash bar entirely from scratch, with no original to scan or model from, replicating every mounting point and thread so it could bolt on exactly like the original. His work was a testament to human skill, stepping in where factory resources ended. Bob's craftsmanship extended beyond the crash bar. He also fabricated replacement radiators to match the car's extraordinary cooling system, which features 10 separate radiators, far beyond almost any road car. These parts fit perfectly, allowing the rebuild to progress despite the absence of official Bugatti components. With these successes, it was clear that Armstrong's team was not just repairing a car, they were assembling a complex puzzle built from ingenuity, skill, and sheer determination. The ability to find solutions without official support was just the beginning. Some of the most surprising engineering fixes were yet to come, blending creativity with precision in ways few anticipated. The story moved next into the realm of unexpected engineering solutions that redefined what was possible in independent hypercar repair. Unexpected engineering solutions. Rebuilding the Bugatti Chiron Pur Sport demanded constant innovation. When Bugatti refused to supply parts, Armstrong's team created alternatives using unconventional methods and unexpected sources. One striking example involved the airbags. Instead of sourcing replacements from Bugatti, the team discovered that airbags from an Audi A3 were fully compatible despite the massive gap between the two vehicles. The finding revealed that even ultra-exclusive hypercars sometimes share common components beneath the surface. It also challenged assumptions that every part in a multi-million-dollar vehicle must be unique or proprietary, highlighting the hidden practicality behind some aspects of hypercar engineering. Another major challenge involved the damaged engine mount, a cast aluminum component supporting the powertrain. Armstrong's team scanned the broken piece, converted it into a CAD model, and CNC machined a replacement from solid aluminum. Precision was critical. Even slight inaccuracies around the crank sensor mounting points could prevent the engine from running correctly. The new part fit perfectly, highlighting the team's engineering skill. Cooling system repairs required similar creativity. Damaged coolant pipes were replaced using sections of rigid brake hose, an unconventional but practical solution that kept the systems operational. These improvisations became a defining feature of the rebuild, balancing innovation with reliability despite the lack of factory support. The gearbox mount posed another challenge. Designed to fail during the crash, it was TIG welded back together, a repair many engineers questioned. Yet the solution proved structurally sound, showing the team's ability to reverse engineer components intended for replacement. Armstrong also noted surprising design choices within the Chiron, including a molded plastic accelerator pedal rather than billet aluminum or carbon fiber. Discoveries like these offered insights into the car's engineering philosophy. Inside, the restoration was equally detailed. Working with E3 Customs, the team retrimmed the cabin to match the original white and purple finish across seats, dashboard, and steering components. The interior looked factory fresh despite the car's salvage history. From 3D printing and custom fabrication to repairing engineered fail points, the project evolved into a showcase of independent automotive engineering, bringing the Chiron closer to its long-awaited first startup. As the rebuild pushed into uncharted territory, the team's inventive spirit proved to be their greatest weapon. What came next would challenge even the most expert assumptions about what could be done outside factory walls. The car's resurrection and impact. After months of meticulous work, the moment finally arrived with the rebuilt Bugatti Chiron Pur Sport start. This was more than an engine test. It was the culmination of countless challenges, technical setbacks, and creative solutions. Armstrong's team reconnected every system, from coolant lines and fuel circuits to wiring looms and the ECU. The entire car depended on flawless integration, and even one mistake could end the project. A major concern remained. Reports suggested the car had briefly run without coolant after the crash, raising fears of thermal damage to the W16 engine. If internal components had warped or seized, the rebuild would fail. Instead, the engine roared to life, producing a deeper, rawer sound than the factory exhaust. A $6 million hypercar had been revived without a single original Bugatti replacement part. Armstrong then drove the Chiron for the first time since the crash. Though not a full-speed test, the car moved under its own power using a rebuilt drivetrain, custom radiators, a TIG-welded gearbox mount, and even airbags sourced from an Audi A3. The rebuild shocked viewers and challenged assumptions about elite automotive repair. Bugatti CEO Mate Rimac had followed the project closely. The same executive who believed the car could not be rebuilt outside specialized facilities now watched it drive again. The project became more than engineering. It questioned automaker control and repair exclusivity. The journey was not without setbacks. Armstrong accidentally crushed a fuel tank pressure sensor during assembly. Rather than separating the chassis again, the team created a new access panel, reflecting the adaptability that defined the build. Over time, Bugatti's stance softened. The company lifted the parts blacklist, lowered some repair estimates, and Rimac invited Armstrong to bring the car to the Molsheim factory for inspection, though he declined. Their relationship evolved from conflict to mutual respect. The rebuilt Chiron Pure Sport now runs and drives, despite being declared beyond repair. More than a restored hypercar, it stands as proof of creativity, persistence, and independent engineering, challenging impossible odds. Its revival also sparked wider conversations about ownership, repair rights, and whether manufacturers should control the future of vehicles once they leave the factory. The project redefined expectations for independent automotive restoration worldwide. Matt Armstrong's resurrection of the Bugatti Chiron Pure Sport shows the power of innovation and persistence to rewrite what's possible. A car declared dead by its maker now runs again, proving that dedication and creativity can challenge even the most exclusive industries. If you enjoyed this story of relentless determination, make sure to like and subscribe for more incredible engineering adventures.